Okay, here's an application of the law of sines. We have a problem that says there's a flagpole located on a slope that makes an angle of 12 degrees with the horizontal. So I'm going to start with that part of my picture. A flagpole is located on a slope. So here's my slope, and here's my flagpole. So I'll even put a little rectangle there so that we can see. There's your little flag. Now, let's see if this slope is about right. It says the slope makes an angle of 12 degrees with the horizontal. So here's my horizontal. And it's probably a little bit bigger than 12 degrees, but anything smaller and I wouldn't have been able to write 12 degrees in there. So there's my 12 degrees. The pole casts a 16-meter shadow up the slope. So I'm going to extend this slope and the shadow is 16 meters. So I've got something like that going on. It's not quite straight. That might be a little bit better. That's 16 meters. Now the angle of elevation of the sun is 20 degrees. So angles of elevation, angles of depression, they're all made with the horizontal. So I can make a horizontal anywhere, and my angle of elevation up to the sun would be 20 degrees. So I'm going to make this a little bit smaller here so that I can draw a sun. So we've got the sun beating down here. And the angle of elevation to the sun is 20 degrees. There we go. So this little angle, make this in green, this angle is 20 degrees. This angle below the horizontal is 12 degrees because alternate interior angles are congruent. So this angle is congruent with this one up here. Horizontals are parallel lines, and then you've got this slope, which is your transversal, and alternate interior angles are congruent. So this angle right here is 32 degrees. Now remember that slope is on a 12-degree incline. So I can continue to make horizontals. This is 12 degrees right here. If this is 12 degrees, verticals and horizontals, which are 90, would allow this other angle right here to be 78 degrees. So here we've got this triangle that is not a right triangle. So here's this yellow triangle. I'm going to come off to the side and I'm going to redraw it. Not in dashed lines though. Something like that. We've got 78 degrees right here. I've got 32 degrees right here. And I want to find the height of the flagpole. The height of the flagpole is this portion right here, which corresponds to that part in the picture. So the height of the flagpole we'll say is h. So I have two angles and a side. So this is angle, angle, side, which tells me law of sines. So now I'm ready to do the math. Because remember, we also have 16 meters here. I've got angle, side angle of given information. So really when I said angle, angle side, that was not given information. We need to go based off of angle, side, angle. Lucky for us that both angle, angle, side, angle utilize law of sines. So my law of sines is going to say that I've got 16 meters over the sine of the angle opposite 16 meters. The angle opposite 16 meters would be 180 minus 78 minus 32. So I believe that's 70 degrees. So I've got 16 over the sine of 70 is equal to h, that's the part that I want to know, over the sine of 32 degrees. From here we would cross multiply. I would have h equals 16 times the sine of 32 degrees divided by the sine of 70 degrees. We would put that in our calculator so that we could get the answer of about 9 meters. Now I will let you figure out what part would be the equation. So I will let you figure out what part would be the equation, hint, hint, and what part would be the answer. Hint, hint, hint.